we will discuss about finite automata. Already we have seen that basics of theory of computation. In this class, we have to discuss about the finite automata. This is actually a abstract machine or basic model of a system. This contains 5 tuple. It is a 5 tuple. It is denoted by m 2 sigma delta q naught f. That means it contains 5 elements. One is q. That q is called set of all states. Set of all states means already we know about the graph. Graph is having vertices and edges. But similar way we can define a finite state machine. That means vertices are here called as states, set of all states, and sigma is input symbols. That is, it is also called alphabets. It may be 0, 1, or it may be A, comma B. These are all input symbol what we are using in this machine. Okay. And delta is a transition function. Transition function means if you are given some input from one state, it moves from one state to another state. That is called a transition. What we are calling this is transition function. This is a function from initial state with for particular input it moves to some other state. Next one is initial state. Here q naught is an initial state. And f is a final state, or it is also called accepting state. While giving some input where the transition ends, if it ends with final state, then the given string or given input is accepted by that machine. Okay, this is the formal definition of a deterministic finite automata. It contains 5 tuple where q is a set of all state like vertices in the graph, and sigma is an input symbol like weights of the edge, and delta is a transition function that is from one state to another state transition, and q naught is initial state where we are giving the input, and f is a final state where it ends, the transition where it ends. Okay, now let us see that an example. Q naught is an initial state. We need to mark this as like a node or vertices. This is called initial state. Another one is final state. We construct with only 2 states, minimum 2 states. While giving 0 as an input where it moves, maybe move to same state. When give 1 as an input, it moves to q1. Whereas in q naught, if you give 0 as an input, it may move to initial state. If you give 1 as an input, it moves to same state. Okay, this is the transition diagram for this finite automata. If we take any string, then we can check whether it is acceptable by this machine, finite automata machine, or not. That we can check it. For example, we can consider one language L is a set of all state such that x s ends with 0, 1. This is our language. Language means what? It is a set of all strings. Language is a set of all strings. Here the strings have some condition. In all the strings, the last two digits must be 0, 1. That means all the strings must ends with 0, 1. Okay, that is the condition here. We need to check whether this string, set of strings, is accepted by this finite automata or not. That we can check it. First we will see that first element. Delta is a transition function. Here Q0 is an initial state. When 0 is an input, where it moves, it goes to what? 0 is an input, it goes to Q0 itself. Okay. Then again we are giving that input Q0 0. First one is value 0, next one is 1. It moves to what? First one is moves to Q0. Again with Q0 1 goes to what? Q0 1 goes to Q1. That is Q1. What is Q1 here? Q1 is an accepting state. If it is double circled, that is called final state or accepting state. If the transition ends with that final state, then the string is accepted by this finite automata. Here Q1 is a final state, therefore given string 0, 1 is accepted by this finite automata, by this DFA. Similarly, we can check some other string. Now let us have consider the string 0, 1, 0, 0, 0, 1. That is also belongs to this set of string. Why we are telling that string ends with 0, 1. That's the only condition. It may contains any number of digits in front, but last it must have 0, 1. Okay, that we can check whether it is accepted by this finite automata or not. Okay, in the same manner, delta of first value is from right to what we have to do, from left to right we have to check all the values. First one is initial state, input is 0. We can write all the values, but we need to consider only the first one from left to right. Okay, where it moves, Q0 0 as an input, Q0 0 as an input, it goes to Q0 itself. That is equal to delta of Q0 itself. Okay, it goes to Q0. What is the remaining value? 1, 0, 0, 0, 1. Next we need to consider this initial state with input 1. Where it goes Q0 1, it goes to Q1. Q1 is an accepting state. Therefore, delta